what to do. Light blue.
Throughout history, many prominent people have experimented with a possible connection between color harmony and sound harmony. Aristotle, Leonardo da Vinci, Sir Isaac Newton. Unfortunately, most of them adopted an arbitrary color scale. Even in our own century, volumes have been written with no conclusive answers. Recently, I devised a formula that produces the correct results. Velocity divided by wavelength equals frequency. Color is measured with a spectrophotometer, and the answers are given in terms of wavelength. Frequency is measured in hertz, or cycles per second. Logic dictates that because of such a huge variance in these two spectrums, that it is illogical to believe that each note will result in a different color. More so would be an idea of a bleed over. The spectrum of color is much higher and covers more ground, so to speak, because of a simple fact. The higher the frequency, the smaller the wavelength. It stands to reason that a lower light frequency, red, will contain a larger wavelength. Thus, a pinpointed frequency will live under a blanket of color. In other words, the color purple will cover all of the frequencies surrounding the note A. To extract the proper color, or colors, for any musical note, all that is needed is the speed of light and the frequency of any chosen note. With frequency, we can properly find the color for any note. Considering we end up with frequencies so high our ears can't make sense of it, we must apply the law of octaves and sympathetic vibratory physics. An octave above any note is found by multiplying the frequency by 2. Working backwards, we can result in the correct corresponding color to audible musical notes. Red and violet are at either ends of the spectrum, just like bookends, just like octaves. Infrared becomes the note B, and ultraviolet becomes the note A sharp. From B up to A sharp is an entire octave, including all 12 notes. The spectrum of red covers more notes and a larger space than the other colors because it is a slower frequency. The frequency of ultraviolet, 466560, divided by 216 equals 2160. How can this be? Ultraviolet divided by 108 is 432.